Hold on to your hats, folks, because the sun's throwing a bit of a tantrum. A severe geomagnetic storm is headed straight for Earth today, and it has the potential to turn our tech-dependent lives upside down. This isn't science fiction. It's a real phenomenon with the power to disrupt communication, navigation, and even our power grids. The sun, despite its life-giving warmth, is a tempestuous beast. It's constantly spewing out streams of charged particles in what we call the solar wind. Occasionally, it throws even more intense bursts of energy our way, like a cosmic sneeze directed right at Earth. These are known as solar flares and coronal mass ejections, or CMEs, and they're the culprits behind the impending geomagnetic storm. Think of it this way. If the sun were a basketball, Earth would be about the size of a pinhead located some 25 yards away. Now imagine that basketball suddenly spitting fire and flinging fiery plasma balls in random directions. So, buckle up as we delve into the wild world of solar storms and how they can impact us here on Earth. Let's unravel the mysteries behind these solar outbursts that are causing such a stir. Solar flares, as the name suggests, are sudden, intense bursts of energy from the sun's surface. They're like giant solar flares, releasing tremendous amounts of radiation, including X-rays and ultraviolet light, at near light speed. While most of this radiation is absorbed by our atmosphere, it can still interfere with radio communications, especially high-frequency ones used in navigation and aviation. Coronal mass ejections, or CMEs, are even more dramatic events. Imagine billions of tons of superheated plasma, a gas made up of charged particles, being blasted into space at millions of miles per hour. These CMEs are like giant cannonballs of energy that travel through space, and when they collide with Earth's magnetic field, they can trigger intense geomagnetic storm. When these charged particles from CMEs slam into Earth's magnetic field, they cause it to fluctuate wildly. Imagine shaking a bar magnet violently. That's a simplified version of what happens to our planet's magnetic field during a geomagnetic storm. These fluctuations can induce electric currents in long conductors like power lines and pipelines, potentially causing widespread blackouts and disruptions to critical infrastructure. The sun also releases a constant stream of charged particles known as the solar wind. It's responsible for the mesmerizing auroras that dance around the poles, and it can also interfere with satellites, causing GPS errors and disrupting communication signals. We live in a world increasingly reliant on technology. Our smartphones, GPS systems, and even our power grids are vulnerable to the whims of the sun. When a geomagnetic storm hits, our tech-dependent lives can be thrown into disarray. Imagine a world without internet, GPS, or even reliable electricity. It sounds like a scene from a dystopian movie, but it's a stark reality we face when the sun decides to flex its magnetic muscles. Cell phone networks, which rely on a delicate balance of radio waves and satellites, are particularly vulnerable to geomagnetic storms. During intense storms, communication signals can be disrupted or even blocked entirely, leaving us disconnected from the outside world. GPS systems, our trusty guides in unfamiliar territory, are also at risk. GPS relies on a network of satellites orbiting Earth, and these satellites are susceptible to interference from solar storms. The charged particles from the sun can distort the signals from these satellites, leading to inaccurate positioning and navigational errors. Perhaps the most concerning impact of geomagnetic storms is their potential to disrupt power grids. Fluctuations in Earth's magnetic field caused by solar storms can induce currents in long conductors, like power lines. These induced currents can overload transformers, causing them to overheat and fail. A cascade of failures can then ripple through the grid, leading to widespread blackouts that can last for hours, days, or even weeks. In 1989, a severe geomagnetic storm caused a 9-hour blackout in Quebec, Canada, leaving millions without power. The good news is that scientists are constantly working on ways to mitigate these risks. As if the threat of a severe geomagnetic storm wasn't enough, we're also dealing with the aftermath of Hurricane Milton, a powerful storm that recently devastated parts of mention a specific region or country. The convergence of these two events, a natural disaster on Earth coinciding with a solar storm, creates a perfect storm scenario that has disaster relief agencies scrambling. Rescue efforts are already underway in the wake of Hurricane Milton, but the potential for communication and power outages caused by the geomagnetic storm adds another layer of complexity to the situation. Imagine trying to coordinate rescue efforts with limited or no communication, relying on backup generators for power, and facing the possibility of GPS malfunctions. It's a logistical nightmare that highlights the interconnectedness of our technological systems and the vulnerability of our modern world to both terrestrial and celestial events. The timing of this geomagnetic storm couldn't be worse. Hurricane Milton has already left a trail of destruction, and the added strain on communication and power grids could hamper relief efforts and prolong the recovery process. This convergence of events serves as a stark reminder that we live in a world where natural disasters and space weather can intersect with potentially devastating consequences. Section 5G4 Alert, a rare roar from the sun. The National Oceanic and Atmospheric Administration, our nation's watchdog for space weather, has issued a G4 geomagnetic storm warning, and it's not something to take lightly. The G scale, ranging from G1 to G5, measures the severity of geomagnetic storms, with G5 being the most extreme. A G4 warning indicates a severe geomagnetic storm capable of causing widespread power outages, disrupting satellite operations, and triggering dazzling auroral displays. What makes this particular G4 warning noteworthy is its rarity. While G1 and G2 storms are relatively common, occurring multiple times per year, G4 storms are much less frequent, happening only a few times per decade. The last time we experienced a G4 storm of this magnitude was in, mention a recent year, and it caused significant disruptions to mention specific impacts. For example, radio communications, power grids. The NOAA Space Weather Prediction Center monitors the sun 24/7, providing timely warnings and forecasts to help us prepare for such events. While we can't prevent geomagnetic storms, we can take steps to mitigate their impact and minimize disruptions to our daily lives. Section 6. The Aurora's Silver Lining, Nature's Light Show. Amidst the potential chaos and disruption, there's a silver lining to this geomagnetic storm, the promise of spectacular auroral displays. For those fortunate enough to live at high latitudes, the night sky may transform into a breathtaking canvas of dancing lights, a celestial ballet of color and movement. Auroras, also known as the northern lights in the northern hemisphere and the southern lights in the southern hemisphere, occur when charged particles from the sun collide with atoms in Earth's atmosphere. During intense geomagnetic storms, like the G4 storm we're currently experiencing, the auroral oval, the region where auroras are typically visible, expands towards the equator. So, while we brace for the potential impacts of this geomagnetic storm, let's also take a moment to appreciate the awe-inspiring beauty of the aurora, a reminder that even amidst the sun's fury, there's still room for wonder and amazement in our universe. Section 7. Solar Maximum, Riding the Sun's Roller Coaster. To understand the significance of this geomagnetic storm, we need to broaden our perspective and look at the bigger picture of the sun's activity cycle. The sun isn't always in a state of high alert, spewing out flares and CMEs with reckless abandon. Like a cosmic roller coaster, it goes through periods of relative calm and heightened activity, following an 11-year cycle known as the solar cycle. At the peak of this cycle, known as solar maximum, the sun's magnetic field is in a state of flux, leading to an increase in sunspots, solar flares, and coronal mass ejections. We're currently on the upswing of solar cycle 25, which began in December 2019, and we're heading towards solar maximum, predicted to occur around July 2025. This means we can expect more frequent and intense solar storms in the coming years, with the potential for more G4 and even G5 events. Just as we track hurricane seasons on Earth, we need to be aware of the sun's mood swings and take appropriate precautions during periods of heightened solar activity. Section 8. Staying ahead of the storm preparedness is key. As we face the dual threats of a severe geomagnetic storm and the aftermath of Hurricane Milton, it's more important than ever to be prepared. While we can't control the sun's behavior, we can take steps to minimize the impact of space weather events on our lives. Here are some practical tips to stay ahead of the storm. Stay informed. Keep an eye on space weather forecasts and alerts from reliable sources like the NOAA Space Weather Prediction Center. Have a communication plan. In case of cell phone outages, have alternative ways to communicate with loved ones, such as landlines, two-way radios, or even old-fashioned written notes. Prepare for power outages. Have a plan in place for power outages, including flashlights, batteries, a battery-powered radio, and non-perishable food and water. Consider investing in a portable generator for essential appliances. Protect sensitive electronics. Unplug sensitive electronics like computers, televisions, and gaming consoles during a geomagnetic storm to protect them from voltage surges. Be aware of GPS disruptions. If you rely on GPS for navigation, be aware that it may be unreliable during a geomagnetic storm. Spread the word. Share this information with friends, family, and neighbors. By understanding the sun's behavior and taking appropriate precautions, we can ride out these solar storms and emerge stronger and more resilient.